I'm Swapnil Mittal, and this is my lab 4 for the class Physics 2211 Section M under Dr. Greco for the class of Spring 2023. The title for the lab is Oscillations. My flow of the presentation will be really simple. I'll introduce the concepts, we'll understand the fundamental physics principles involved in the lab, we'll observe the motion of a spring and an object connected to it. We'll compare our computational result using GlowScript with what we have observed using the tracker app. We'll also discuss if the energy principle is satisfied and compare the time periods. The basic fundamental physics principle involved are the Newton's second law, which says that the change in velocity divided by the change in time gives the net force on an object divided by its mass. I have also put in the velocity update formula and the position update formula. The only non-forces affecting the motion are gravitational forces and the spring force. I have also put in the formula to calculate the spring constant K and the relaxed length L0. These are the equations to calculate energy, the kinetic energy formula and the potential energy due to gravity and the spring. Also, my choice of the system is the earth plus the spring plus the mass. So the net change in energy is 0. Therefore, the system does not lose any energy. Let's see the video once. As you can see, the graph for the object and its motion with the spring has been plotted. Here are some observations. The mass of the spring has come to almost 0.4 kgs. The starting time was obviously 0 seconds and the initial position has been calculated. We have used the velocity update formula, the average velocity formula and the time of last observation. The results are like this. The time period is 1.52 seconds. The spring constant has been calculated by the formula given above, which is 6.86 Newton per meter. And the relaxed length is 0.126 meters. Here's the computational model with the code where I put in my observations for spring constant and relaxed length. This is my GlowScript code if you guys want to check it out. Here's another chunk of code which I changed a little, but not a lot. As you can see in the graph, here's another chunk of code, and let's analyze the observations. First, we'll analyze the errors. As you can see, both of the graphs are very much similar, but a little off. This is because the initial velocity might not have determined properly. The object might have been swinging in the z direction, and there are a few non-zero forces that we haven't taken into account. In the future, we could capture more frames per second and also perform this in the lab conditions. As you can see, the orange line stays at 0. Which means the total energy of the system remains 0 and the energy principle is satisfied. The time period from x and y. The time period from y and the time period from x at the start remain very similar, but get off a little more at the end. Thank you so much for patiently listening to my presentation. I hope you graded well. Thank you and have a nice day.